So jetpacks. Jetpacks are quite a visual thing, so I thought the easiest way to start is with a video. Come on, go video. Okay, technical issues.
This is the Martin Jetpack. The world's first practical jetpack. Has the ability to climb at more than 5 meters a second, and it can cruise at over 100 kilometers per hour. Sounds like a lot of fun, right? Now let's see where the jetpack is going to be seriously useful. Frontline emergency personnel around the world who need to get to people fast. And in places where you can't land a helicopter. Search and rescue teams working in the most hazardous terrain.
In case you're worried, this is the whole
military personnel worldwide who need to move around in a fast, nimble way. Customers who want to use unmanned jetpacks in areas too dangerous for people. Lifting people to safety, delivering supplies, sending back vital information. This isn't the distant future, it's right now. Within 18 months, the Martin Jetpack can be in commercial production. So far, we've had expressions of interest from 6 militaries around the world, many search and rescue teams, and emergency response providers, a wide range of commercial organizations, and literally thousands of recreational aviators. They can all see the huge potential of this aviation breakthrough. Right now is your chance to become a part of this New Zealand success story. The timing couldn't be better. The Martin Jetpack. Fly the dream.
Great, thanks. Thank you very much. I mean, this all goes back to the original idea of flying, which was, we were going to flap our arms and fly around, and this is, the famous lithograph of Icarus and Daedalus. By the early 1920s, the idea of that became the idea of a jetpack, that you were going to strap in and fly a jetpack. And the only real sort of success in that thing was funded by the US military after the Second World War for the military, and that was the Bell rocket belt. And it was a great proof of concept vehicle. It's still amazingly exciting whenever anybody turns up with it anywhere in the world. Tens of thousands of people turn up to watch it. But it had a few issues. Being a proof of concept, it could only fly for 26 seconds. The fuel you use on it is incredibly dangerous, and it was very, very difficult to fly, and you had to weigh less than 130 pounds. So in the early 1980s, I decided to look at this problem. while I was at university and I set myself the parameters of building a practical jetpack, something that runs on gasoline, can fly for at least half an hour, can lift a real person, and as I weigh 220 pounds, I define that being as 220 pounds. And that started a long history of developing this jetpack which we have today. So it's vertical takeoff and landing. Thanks to a US company called Rockwell Collins, it's now all fly-by-wire. So you strap into it and you use the joysticks to tell you the computer where you want to go. So it's very much like a computer game. You don't fly it directly. That makes it very simple to fly, and we've literally had people come in off the street and fly it within 20 minutes of being in the building, going solo. And there's no way you can do that in any other aircraft in the world. That's the basic specs for our introductory model, but we have specs for future ones that will fly up to 2 hours, and we have a product in development for the US Navy that will fly up to about 3 hours. Runs on the same stuff you put in your car. It's designed from the ground up to have a parachute built into it, and our current parachute will work from about 15 feet. So even from 15 feet you can be purely rescued with the parachute alone if you make a mistake, and the classic mistake is not putting enough fuel in. Obviously it's got a roll cage and all those sorts of airbag technologies that we have in cars these days built around it. It's hands-free, so if you're flying along and you're not too sure what you're doing, if you let go with both hands it'll just sit there and hover. So that's where the computer has made it a lot safer. And I originally had this idea that it was going to be purely a recreational toy, because that's what I wanted it for. I was going to sell it to the same people that have Harley Davidsons and snowmobiles and personal watercraft. And we've had quite a lot of those people, about 2,700 of those people front up and say they want one. But we've also had a lot of interest from the government, search and rescue, military, police. And we've sat down with those people over the last 3 years and listened to their operational scenarios and what they want. And that's where this red one, the new one, P12, comes from. So it's really designed around their operational scenarios. So obviously to do this and do it something that nobody else has ever done in the history of the world, you've got to develop some new technology. So we've got 4 patents around there at the moment, and a 5th one just being filed around the parachute. Our patent attorney is actually in California. It's the same patent attorney that the Virgin Galactic use for the Virgin Galactic spaceship. We've already flown it up to 5,000 feet, which was a fun day, and then turned the engine off and fired the parachute. My wife wanted to be the test pilot that day, but the aviation authorities said no, so in the end we had to put a crash test dummy in it, which we were very disappointed about. Now, if you're wondering what a jetpack looks like when it's 5,000 feet above the Canterbury Plains in New Zealand, that's what it looks like, so it's pretty hard to spot. It's also very quiet when it gets up there, you can't hear it from the ground. And as we said, capabilities, it can get into small, tight places where you can't go with helicopters. Because it's all electronic, you can also take the pilot out of it and fly it unmanned. And we've flown some samples unmanned for various military customers. These are some of the things that the military and the government and search and rescue people wanted to use it for here. So obviously I'm the founder and the inventor. Did a lot of research obviously on jetpacks in the early 80s, but also a lot of research on businesses and inventors, and saw where they went wrong. And a lot of that was around the business side of things. So I've always had a vision of building a company. Brought in a lot of capital over the years to develop this. We're looking for about another 5 million at the moment. Brought in a board of professional directors, a VC capitalist. Dennis Chapman started an electronics firm in New Zealand and sold it for $100 million a few years later. David Hunter was the CEO of Accenture, which is some of your software guys probably heard of. Steve Bayliss was marketing manager for Air New Zealand, which is arguably one of the most successful, I shouldn't say in front of the Aussies because of Qantas, but arguably one of the most successful tier 1 aviation companies in the world. And we've headhunted a chief executive from Lockheed Martin. He's an ex-RAF fighter pilot and successful businessman, and brought in a German engineer, which is apparently, if you want a good engineer in aviation, you have to have a German engineer. I think the American aviation industry understood that quite well in the 1940s, and it still carries on to this day. So that's our team. The market potential is an interesting question because, nobody's ever really gone out there and sold a jetpack before. So we've looked at, comparable markets. What happened when the snowmobile was invented? What happened when the jet ski was invented? And we've looked at comparative markets like that. We've also looked at the aviation market in different niches and that gave us an idea of how big it might be. And since then, as I say, we've had over 100,000 inquiries through our web page. We've got a database of 10,000 people we interact with regularly, and we've got over 2,500 people who want one when it's ready. And we have some more formal arrangements with some people and some governments and militaries, some of them which we're allowed to talk about, and obviously quite a few of them we're not. I express it in this way, and interestingly enough, the jetpack market turns out to be very similar to the helicopter market. We don't really compete directly because we can do things that they can't do, and they can do things that we can't do. But in some ways it's very similar. It's all around search and rescue, recreational training and such forth. The jetpack is, it turns out I was surprised that it's quite a darling of the media. When I turned up at Oshkosh with it in 2008, I was hoping that we'd get 100 people turn up. We ended up with 10,000 people turning up to Oshkosh. We got asked to be on the Jay Leno program and the David Letterman program. We got asked to go and have a photo shoot with a jetpack in California at a place called the Playboy Mansion with the pilot. Unfortunately, the pilot was my 16-year-old son, and Mum said no, so he wasn't allowed to go to the Playboy Mansion. So yeah, it turns out every time we go somewhere with a jetpack, thousands of people would turn up. Obviously we would have loved to have brought it here, but the logistics of that is a little bit difficult at the moment. So we're planning on doing, I suppose, what you might call a public launch for it, actually showing it to the world later on this year. And obviously, the places we're looking at are New Zealand, Australia, and the US. And the US is, to New Zealanders and the Australians, US is West Coast. East Coast is a little bit more difficult with the time zones. So I still love the idea of flying it up and down Wall Street though, but never mind, one day. So we've been funding this through a lot of investors, government grants, people who are interested in it. It started off with a group of engineers who could see the vision, and now it's grown into professional investors. And our current round, we're looking for 5 million New Zealand dollars, which is about 4.2 US, and that will commercialise that product there, which is now flying, and that will get that in customer hands by the end of this year. And then there'll be probably opportunities later on. Obviously there's an IPO in our future, and we're looking for large partners as well. Well, that's probably enough. I'll go to questions, and while we've got questions, I might play a video with the sound off.
Questions about a real live jetpack? I know there's got to be some.
How do you avoid collisions with existing aircraft?
So I didn't quite hear that.
How are you imagining that collisions with existing aircraft will be avoided?
Yeah, well, at the moment, how all aircraft avoid each other is usually visually. You look out and you try not to bump into people, which sounds a bit basic and simple, but that's how 90% of the aviation in the world works. The 10%, which is commercial, you've got radar tracks and there are certain flight paths and things like that. But we don't fly in that airspace. We fly in what they call Class E airspace, which is a lot lower, which is what they call general aviation, and we'll be flying in that airspace. Having said that, NASA and the FAA are working on this highways in the sky scheme, and they've already tested that. Basically, it's 3D GPS mapping, and that's probably arguably a lot more reliable. And that may come in. The big hold up on that at the moment is actually the air traffic control unions in the United States of America. The last thing those unions want is automated software flight controls. So that's a political problem rather than a technical one. Yo.
Hi, I'm very excited to hear about your presentation. This is my dream. When my if not in my life, my daughter will actually take her children to school with these jetpacks.
Exactly, yeah.
That's what I talk to my daughter all about. And just on the practical side, what is the fuel used?
Yeah, I decided this was going to be a practical jetpack. So it's what we call petrol and Americans call gasoline. It's the same stuff that you put in your car. So it is actually a piston engine. So it's an internal combustion piston engine with pistons and spark plugs, and it can be maintained by the same people that maintain cars and motorbikes and trucks.
And what's the weight at this stage of this device?
Yeah, well, there are two classes. In the US, there was what I call the ultralight class, part 103.2. And for that class, you're limited to 254 pounds for the aircraft, and you're limited to a 5-gallon fuel tank. So that gives you 20 minutes or 30 minutes flight time. If you take it outside that class, and that is possible for the military and search and rescue, then you can have a slightly bigger aircraft, and that's the red one for the search and rescue people. So that'll fly for a lot longer, carries more fuel. So basically the weight of the aircraft is between 115 kilos and about 180 kilos. So about half the weight of a Harley Davidson motorbike, to put it in perspective.
And you mentioned in early prototypes, like the one that Bell Labs was developing in the 50s, that it had a very low weight limit for the pilot. How, can you carry a normal size adult, a big adult guy in one of these jetpacks, and could you pick somebody up if you're in the search and rescue scenario?
Yeah, I mean, we're happy to build a bigger one where you can lift 2 or 3 people, and we have some search and rescue people looking at that. The current one will lift, I'll put it in pounds, it will lift 250 pounds. And hopefully not too many people go over that. You can, obviously, if you've got a lightweight pilot, lift somebody up. But usually what we're talking to with the rescue thing is somebody flies in a jetpack and they have what we call an electronic mule train. So electronically tethered to you, 20 feet behind you is an unmanned one, and that's what you pick up the person with. And the fire people are talking about a fireman flying to the top of a building, you land, you strap somebody into it, you flick a switch, and then the fireman can then fly it down, drop people off and ferry them backwards and forwards. And you only need, a space this big to land in. It's not like a helicopter where you've got these big rotors that tend to bang into things, so you can sidle up. We've flown into the side of a building a couple of times accidentally, and, it doesn't really do any harm. But
How many working prototypes do you have?
Well, we're on prototype 12, and I think we've still got 3 prototype 11s that are flying and 2 prototype 12s, so we've got about 5 that are flying at the moment.
How much petrol or gas do they use?
Sorry?
How much gas, how much petrol do they use?
Yeah, it's not the world's most efficient way of getting from point A to point B. Obviously, if you're very eco-friendly, we should have all ridden our bikes here today, but it depends what you compare it with. I mean, it's probably about 8 miles per gallon. But if you compare it with a Black Hawk helicopter, then it's very fuel efficient. And obviously we have some militaries who use Black Hawk helicopters who are looking at something that costs $60 million, and they're replacing the task that aircraft can do in certain applications with something that costs $300,000 and burns 1/20th the amount of fuel. So in that situation, it's very fuel efficient. So it's almost a throwaway item for some of those people.
This is clearly a lifelong dream for you. What stage do you think, how much longer do you think it could take to get your Martin Jetpack into commercial production?
Yeah, well, we'll have, assuming our funding, and I don't think $5 million is it. We've raised a lot over the years, so $5 million isn't a big ask. Assuming that funding comes in the next 8 weeks, we'll have commercial product in customer hands by the end of this year. We have some military/search and rescue organisations who are just waiting for them, and they want 2 or 3 each to try out and do some certain things with, and then we'll obviously grow from there.
Any other questions? Last one.
Yeah, well, weather's interesting. I mean, originally I designed it as a recreational vehicle, so I don't want to fly out in a jetpack on a rainy day or in the snow. It just sounds horrible to me. But as soon as we got approached by the military, they said, we want something more. So to put it in perspective, at the moment it's designed around the Robinson R-22 flight envelope. So wherever you can fly a Robinson R-22 helicopter in the same sort of winds, we're actually a little bit more tolerant to wind than an R-22. But yeah, no, so it's okay. I mean, you don't really want to fly it in the middle of a hurricane. It's not quite up to Black Hawk standards when it comes to weather, but the military is pushing us to do that, particularly the Navy. The Navy want us to be able to land on pitching ships in what they call Seascape 4, and that's quite a task. So again, you know, we have a whole group of engineers who sit down and simulate and then test these things, and it keeps on getting better and better each generation. Okay. Right now, a bit of marketing question. So, who here, if we had a jetpack here and we charged you a small amount of money, like a couple $100, would go for a flight in a jetpack?
No doubt.
Okay, and who here would buy one if it was $150,000? Yeah, so that's about what we get. I mean, and we have another business which is around that, which is basically people coming in, paying money, just like you do to go bungee jumping in New Zealand, and we have a lot of interest in that as well. So those numbers are about normal. So you Americans are about as gung-ho as everybody else. Some countries, no, nobody will do it. And the two that put their hands up and want to buy one, you better come and see me later. Thank you.